In this video, we're going to focus on fraction representations. We won't be talking about operations of fractions until the next one. So what are our essential questions about fractions? The minute as an instructor or presenter, I say, hey, we're going to play with some fractions. We're going to focus on fractions. Teachers panic. Not just kids, but teachers panic. Why is fractions such a brick wall for us? So one activity that I do in a live class, and we can't do here, is I'll put up a large chart paper and I'll say, why is fractions a brick wall? Why does it cause us anxiety? And I'm going to just read to you some of the comments that often are thrown up there. And I'm writing as fast as I can, but there are usually lots of reasons. So some of the reasons are it doesn't follow the rules of numbers, starting at 1, getting bigger. Preconceived ideas that they're bad. Vastness of what is inside a number, the values doesn't recognize. Friendly numbers, the lack of truly understanding fractions, moving from groupings typically by base 10 to a fraction being groupings of any numbers, shifting from concrete to abstract. Student thinks it's something that's brand new. There's no connection to whole numbers, and it's highly abstract. So hopefully you're not panicking and that we'll be able to move forward and help strengthen your understanding of fraction concepts. So fraction development actually starts in most kindergarten standards, but they're not under fraction standards, they're under geometry standards. So K2 fraction standards typically are housed within the geometry standards. They're learning the attributes, which we just learned about in our previous module, how to compare them, how to classify them, how to name them. And then they're also looking how to partition. What does the vocabulary development of halves, wholes, fourths, quarters? They don't yet have to know the symbolic notation until we start working with them, typically in third grade. Now, in third grade is where we focus on fraction representations, comparing and equivalence, and fractions as numbers. There's usually not real operations in third grade. A lot of times our books have adding and subtracting fractions in third grade, but I want you to take some time and go look at your actual state standards and see if there's operation of standards. If there's not, you've just freed up a whole bunch of lessons to really focus on fraction representations. Now in fourth grade, we're going to formalize equivalence. We're going to continue comparing fractions. We're going to start to add and subtract. Usually there's a beginning concept in fourth grade and then the finishing concept in fifth grade. And then also we're going to start multiplying fractions, and it's continued in fifth grade. So fifth grade is formalizing all of these operations. And then it adds this idea of scaling, this idea that I have a unit and it gets big by the scale. And then I start to divide. Now, understanding your standards is going to be super critical in recognizing how deep you need to go. As a fifth grade teacher, I was stressing out. I was mapping out all of my fractions units. There were 2 full units, and within those units, there were multiple lessons. And I was just like, oh my gosh, I feel like I only have, I think I had something like 7 weeks for these 2 units. And I was venting to my colleague, and she says, but you don't have to do division. And I was like, what? And she says, no, let's look. And we looked at our standards, and fifth grade standards in Idaho said that I did a whole number divided by a fraction and a fraction divided by a whole number, but not till sixth grade did we have to even begin to explore a fraction divided by a fraction. So I went to my textbook, and dividing a fraction divided by a fraction was almost a third of the total content. That just freed up a ton of time for me, and I could actually spend time on my state standard expectations and go deep and have that time to go deep. So really take a look and compare your standards with your curriculum. Next, you're going to watch another Graham Fletcher video, which is like my favorite stuff, and it will be his fraction progression. So these are the same ideas that are related to number sense and whole numbers and how it all relates to fraction. It's the same ideas. Now we're going to get into the structural components of a fraction. You have three structural components. You have equivalence, units and unitizing, and iterating and partitioning. So we're going to break these up. There are a few common fraction representations. When students start off, we often want to be thinking about bar models because they're easy to partition, especially by folding, and they connect really nicely to a number line. We can also challenge students by thinking about areas or regions, and that also becomes handy for multiplying and dividing fractions, as we'll see later. I'm going to make note that partitioning circles is really difficult, especially for kids who are just learning about fraction concepts, but for adults as well. They're also hard to connect to a number line or to a regular area model. So while we often see fractions represented with circles, we really recommend using bar models, rectangles, and number lines, which connect very well. Now, pizza pan, brownies, they always work as contacts, but we can also use those in rectangles. Now, you don't have to steer clear of circles, but we do need to recognize that they're particularly challenging. What you'll also see are a set of discrete fraction representations, which get at the ratio concept, but we still use fractions to represent them, and we'll talk about that in a little bit. But when we look at these representations, they can be hard as a starting place for students to think about because it's not connected together as a whole. It's hard to know what the whole is. So this is an idea that tends to appear later on. What ideas are some of these students missing? Which students correctly interpreted the task? Does it need to be addressed explicitly, maybe after the participants share their takeaways? Or maybe it's a whole group discussion. Be mindful of using the word participation or partition and iterating. Unit iteration is a form of composing where we are using equal-sized pieces to build up. For example, we can iterate a unit of 2 4 times to get 8. Iterating is closely tied to measurement, where when we measure a pencil, for example, we iterate 1 centimeter units to see how long the pencil is. This idea is the same for fractions, 1/6 and 1/6 and 1/6 and 1/6. This is early number development, hierarchical conclusion. Man, say that fast. When we divide a quantity into equally sized units, we're partitioning. For example, we can partition 10 into 5 equal units of 2. Again, this is closely connected to measurement, where we can partition a unit of measure to create a new smaller unit of measure, like partitioning centimeters to get millimeters. Iterating and partitioning are central concepts for understanding place value, multiplication, division, fractions, and decimals, proportional reasoning, and measurement. In fact, these concepts extend all the way through calculus. Press pause to do this task. Press play when you're done. Take a few minutes to try and do this activity on your own. I'm putting the numbers up here. For example, on that first number line, if I start with 0 and then I go to 1, I'm going to place the 1 on the number line. And then how would I find 2/3? Would I iterate? Would I partition? So go ahead and do that and see if you can use that iterating versus partitioning language. And then the same with the second one. If I start at 0, I go to half, how do I then find 1/2? Now let's connect this idea to this idea of iterating and partitioning to our normal symbolic fraction notation. So we have the numerator and the denominator. The numerator is how many pieces we have. The denominator is how many pieces are in that whole. So let's take the fraction of 3/4 right here. That is an iterated fraction. That is 3 1/4 pieces put together. So I have my 1/4, 1/4, 1/4. So when we are looking at our 3 1/4 pieces and they come together to make a piece that we call 3/4, that is the same thing as saying I have one piece, one piece, one piece. What are all those one pieces? I have 3 pieces. I have 1/4, 1/4, 1/4, and now I have 3 1/4 pieces. So now we've just discussed iterating and partitioning and the idea of a unit fraction. A unit fraction is the one piece, the 1/4 piece. Put 3 of those units together and we have 3/4, but the unit is the 1/4. That idea of unit fraction is really important. So next we're going to look at units and unitizing. All right, you have this activity in your pause and play documents. I want you to take a second and see if you can identify which shape, if the whole thing, which is, let me grab my pen, if the whole thing is this shape right here, so which one of these squares represents 1/12? Which one represents an 1/8, 1/16, 1/32, and so on? Press pause and then hit play when you're ready to go on. Now, I'm not going to demonstrate all of these, but I'm just going to show you just 1 or 2 ways of how you can think about it. So let's start with the 1/12. If I have, one way that I looked at it was I'm just looking at this half right here, and I see this line cutting this all the way over, and I'm going to continue it over. Well, by doing that, I now see 6 places or 6 boxes. And I know that if I have 6 on this half, then I'm going to have 6 on the bottom half as well. I hope you can see my laser there. So on this bottom half as well. So that means I'm going to have 12 total boxes. So I know this one is an example of 1/12. There might be others as well. So how we look at these can be completely different, but this is one way that we can look at seeing different units. Now this is another way, but that could be shared with kids, but we go in the reverse. We could ask kids we highlight a piece and we ask them what we know. So we know it represents, like, let's look at A. So A equals how much? I know because, and then they have to justify it. So whether they break it up by doing like this, and I know that's 1 out of 4, or however they choose to break it up. What's fun is when they start to justify ones like this, like number C. So this is another way to look at developing that unitizing idea. One last concept that comes out of these types of activities is equivalence. For example, this shaded area can be represented symbolically in multiple ways, depending on how we partition the space. We can think of it as 1/24 because it would take 4 to fill in this rectangle, and then it would take 6 of those to fill in the entire circle. I'm going to draw my circles here. But if we partition further, that blue area is also 2/48. We've doubled the number of unit pieces that it takes to fill the hole. So right here, 2 of these, I believe this is 2/48. So we need twice as many of them. We're looking at the small squares, these ones. The blue area is also 496. Again, if we've doubled the number of units it takes to fill the whole area, so we need twice as many to represent the same fractional amount. Eventually, we connect this idea of equivalence to multiplying by an equivalent of 1. But initially, we can connect conceptually to iterating and partitioning. Take a minute to do this task. And if you don't have Cuisenaire rods available, then here is a website that you can go to that has digital Cuisenaire rods. And if for whatever reason this QR code or this link is not good, then all you have to do is do a quick Google search of Cuisenaire rods virtual manipulatives, and there's some sort of resource that will be available to you. So hit pause. Once you have an answer to all of these questions, this will be in your pause and play document. Then hit play, and you're going to watch a video about that demonstrates the thinking and how to use these. And just to introduce you to Cuisenaire rods. Okay, so using those same Cuisenaire rods or fraction rods, try this task. Hit play when you're ready. All right, last set. Try these. So this task will use pattern blocks. So just like with the Cuisenaire rod tasks, use this QR code to take you to some virtual pattern blocks and try this task. The exploration is really the interesting part. So maybe try to find somebody to do them with, a partner, a child. It's really a fun exploration. If for any reason the QR code doesn't work or the link is broken, a quick Google search for virtual pattern blocks will help you find a replacement. If you happen to have pattern blocks lying around at home like I do, then use those. Just like with whole numbers, we can connect to our fraction understanding to whole number relationships. They're all the same relationships. We have spatial relationships, which is having a picture of the number, including where it lies on the number line. You can have a unit more and a unit less. So if I have 5/4, what is a fourth more or a fourth less? What is 2/4 more or less? We can use our benchmarks of 0, half, and 1 whole. Is it above 1/2? Is it below 1/2? How far away from 1 is it? We can also use our part-whole understanding, knowing that 3/4 can be broken into parts. So I have a half and a fourth, or 1/4 and 1/4 and 1/4. Same relationships. So here's a few more ideas that you can spend some time developing this unitizing idea. So example on the left, if each, you know what unifix cubes are, if each cube is 1/6, I could say to kids, show me 3/6. How would you describe what you built? Now I want 4/6. What did you do? That's that one more. If each unifix cube is 1/5, show me 4/5. And how would you describe it? Well, what would be 2/5 more? We spend a lot of time skip counting with our littles, 2, 5s, and 10s. We should. Let's move into comparing. How would you compare each set of fractions based on understanding without finding a common denominator? That's the goal. Without finding a common denominator. Based on the knowledge of what the numerator and denominator indicate. So hit pause and see if you can compare these. Think of your benchmark. Think of what the numerator means, what the denominator means, and then hit play when you're ready to continue. All right, so let's discuss these. This can lead up to some really powerful discussions with your kids, and it could take 2 to 3 weeks of really direct instruction to get these ideas across. These discussions are super powerful. So let's look at the 5/8 and the 3/8. How did you determine which was greater and which was less without having to think about common denominator? Or I guess converting to the common denominator. So we do have the same bottom. So this is going to be more, and this is going to be less. Another way to think about it is this is one more unit. I'm sorry, I said this and that without having my pencil going. The 5/8 is one more unit than a half, and the 3/8 is one less unit than a half. So let's look at 5/9 and 5/11. Now, I actually have a common numerator. I can use that understanding. So if I have 5 out of 9 pieces, that's going to be greater than 5 out of 11 pieces. Another way to think about it is the 9 pieces are going to be larger than the 11 pieces. So 5 of these pieces are going to be bigger than 5 of those pieces. All right, let's look at the 5/8 and 4/9. 5/8 is 1/8 unit over a half. 4/9 is 1/9 unit under, or I guess it's half a unit under 1/9. It's under a half. And let's look at 6/7 and 7/8. Now, both of these are 1 unit away from one whole. But if we look at a number line, and this is my whole, let's talk about the size of pieces for 7 and 8. These 8 pieces are going to be smaller. So a 7th, or I guess an 8th, 7 out of the 8, it's actually going to be closer. And then if I have 6 out of these, they're bigger pieces, but it's going to be a bigger 1/7. So it's going to be bigger farther away. I don't know if that made sense. Hopefully it did. All right, and then when we look at 9/8 and 7/8, this is the same idea as up here, except they're both 1 unit fraction over a whole. In whole number understanding, we relate to benchmarks all the time. We need to use these ideas when we're talking and comparing fractions as well. Now, decomposing numbers is really important as the transitional piece to when we add and subtract with fractions. So let's take this 7/8 and decompose it in as many ways as possible. For example, let's see if I can do this. Oops. Turn off my pen. Okay, so for example, I can do 7/1/8. I can also decompose it by saying a half, a fourth, and 1/8. So what other decompositions can you come up with? Hit play when you're ready. So some of the other ones that I came up with, and you might have come up with different ones, are things like 3/4 and 1/8, or a whole minus 1/8. And yes, that last one is a decomposition of 7/8. Now, just to give you, we're going to get into fraction operations in the next video, but I really want to take a minute to show why flexibly decomposing fractions can change your world. It is so crucial. So let's look at how we can use our decompositions of 7/8 to figure out each of these fraction problems. And what you're going to see is never once do we have to find common denominators. It's amazing, and it uses number sense. So, for example, I'll do the first one, and then I'll give you time to do the next two. So 7/8, I know I can decompose this into a half. Sorry, my writing's not really great. And what is it, 3/8? Because I know that's 4/8 and 3/8, right? And I'm going to do a tree diagram. All right, well, I know, I'm getting a different color. I know now I can take that half and combine it. So now I have my 2, my 1 whole, and I have my 3/8. So I have 3 and 3/8 as my answer. Isn't that pretty amazing? All right, take a minute, hit pause, and see if you can solve those next two in something similar. All right, so in this video, we really looked at just the number relationships, the fractional units, iterations, and iterating and partitioning, and then comparison and equivalencies. So in the next video, we're going to talk about operations. So I'll see you there.